Hello, I wanted to go over the built-in web interface on the ILDAC-32. Has a built-in web server that you can access with any web browser that's on the same Wi-Fi network as the ILDAC. I'll cover connecting to the ILDAC via Wi-Fi and Bluetooth in another video, but you can use any browser to connect to the internal web server. Up top we have the basic test patterns that are built in that come with every unit used for tuning and alignment. I'll go through these really quickly. The all colors sharp dots, blanking shift, color test dark, light, medium, grayscale, grid, ILDA-12K pattern, JM color test, laser media, orientation, quadrature, and crackers. Come back to that later. Standard invert X and Y. If you need to flip these things for your particular projector, flip the axes, flip the X and Y axes, and let's go back. There we go. Point optimizer and preview window I will cover briefly in another video, so I'm going to skip over those for now. Flip OLED display. There's a 4-line OLED display in the ILDAC unit itself. If you have it upside down, you can flip the display so you can read it however it's positioned. Coming down, we have the standard settings you can change for your projector. Scan rate, right now I'm at 32,000 PPS. In non-optimized mode, the ILDAC can go up to 40,000 PPS, and in optimized mode, a little over 70,000 PPS. So I can change this. I can bring this down, and you'll see it adjusts right away. It tells you the target and the actual PPS and how close it is accuracy. It gets within 0.01 or 0.02% for most settings. I have it set for 32,000 right now to minimize the flashing on the camera. Usually I run it around 28 or 30,000 for this X-Laser Mobile Beat Mirage that I have. Scan size, self-explanatory. You can bring that down to reduce the size and angle. I'm recording it about 60%, so it fits in the frame of the camera. We can go up pretty high to 100% if you need. Blanking shift, let's go to the blanking shift test pattern. Changes the delay between the color and the X and Y being sent to the DACs. So you can shift this forward and back as you need. A shift of 3 or 4 points is about right. We can look at the ILDA-12K pattern, and right between 3 and 4 puts us right where it should be. Brightness, self-explanatory again. You can bring that down if you need to lower the intensity. X and Y offset. The ILDAC internally has potentiometers for X and Y gain and offset to adjust for your particular situation. But if you need to fine-tune that, you can change the X and Y offset here, either direction, and then reset it to 0 if you need. And the same for Y offset. We can go up and down small increments if you need to fine-tune the Y offset. Coming down a little further, the Status area shows us our current pattern that's being displayed. Uptime of the unit, 15 hours, 27 minutes. Free memory, this varies when you're running animated ILDA files that may have large frames, and the min and maximum memory that's been used over the course of the uptime. The SD card size is 2 gigabytes, comes included, and how much is free on the SD card. The firmware version running on the ILDAC-32. There's a serial console for debugging if you have it plugged into a computer. You can get some output that tells you some of the internals of what's going on. It's not required for most uses. The Wi-Fi SSID that it's currently connected to, and the Bluetooth device name if Bluetooth is enabled. Right now Bluetooth is not enabled, but I'll cover that again in another video. And point draw tells me how many microseconds it's taking the device to draw each point in the frame. So right now we're at 17 microseconds. If I turn the point optimizer on, that drops down significantly. But check out the follow-up video on the point optimizer and the preview window for more explanation on that. Coming down, we have shapes and beams, which are some real simple oscillator. Puts up a square wave, which is a square. Sine wave does a circle. Sawtooth wave gives us a sine wave design. Triangle wave gives us a diamond. And a Lumia Q I put in here is a very small circle for shooting through diffraction gratings or torture tubes or what have you. For each of these shapes and beams, we can change the speed at which the colors cycle through the RGB palette. It's the 8-bit RGB palette. We can go through very quickly, and you can see that changing, or we can slow that down if you want a very slow color change cycle. The same with the shape frequency. If this is a circle being drawn, we can slow that down to be very slow. If you want to just move the beam very slowly through diffraction grating, you can do that. We can slow it down even further, and we can speed up the color change. So either way. Coming down to this row, these are just static beams. 0, middle, and high shows us the absolute 0, 0 point, the middle point, and the high point of the scanners. These also respond to the brightness setting up here. If you need to lower the brightness, I'm sure it's overloading the sensor in my camera right now, so I'll lower the brightness a little bit and see if this is a little bit better. Low, medium, and high. These are static color beams, so we just have red, green, blue, magenta, yellow. That comes out as green. Let me raise the brightness a little bit. So there's more magenta and cyan. And of course this solid white beam right in the center. These are all absolute center of the scan field. So let me bring the brightness back up, and I'm sure it'll overload my camera. Okay, so that's the shapes and beams.